Hi there. Now in part A we're given that 2 times the log of x minus 5 in base 3 minus the log of 2x minus 13 in base 3 is equal to 1. And we've got to show that x squared minus 16x plus 64 equals 0 for 5 marks. So at this point, if you haven't done this and would like to have a go at this question, I'll just give you a moment to pause the video. Okay, welcome back then if you had a go. So let's just take the question, we'll copy it down first of all. That is the 2 times the log of x minus 5 then in base 3 minus the log of 2x minus 13. That's 2 in base 3 and it equals 1. Now in order to show that this is going to come out as x squared minus 16x plus 64 equals 0, what we've got to do is group together our log terms here. And I can see that we've got a log essentially take away another log, but we have a slight problem. Remember that this rule, the log of a minus the log of b in base c, is identical to the log of a divided by b in base c. But there's no value in front of the log here for this rule to work, and we've got a 2 here. So we've got to get rid of this 2 first of all. And so we look towards the power rule for logs. N log a in base c is equal to the log of a to the power n in base c. We bring that power up to the top. So we need to remove that 2 then by using this rule. We can say that therefore we've got the log of x minus 5 then in base 3, but it's now all squared, minus then the log of 2x minus 13 in base 3, and this equals the 1. Now I've got a log of a value minus log of another value, so I can use this rule here. And now I have the log then in base 3 of x minus 5 all squared all over 2x minus 13 equals 1. So I've now got 2 terms, one term on one side of the equals and one term on the other side of the equals. So you've always got to reduce log equations down to this form. Now that we've got it this form, we can anti-log. And for something like this, I'm saying that the log of a number in base c, let's say it equals p, means that it follows that that number n is equal to the base, c in this case, raised to the power p. So when I compare this result to this one here, I can see that n is this value. So we've got, therefore, x minus 5 all squared divided by 2x minus 13 must be equal to the base, which is 3, raised to the power 1. Well, 3 to the power 1 is going to just be 3. And all I need to do now is just multiply both sides by 2x minus 13. So we've got x minus 5 all squared equals 3 lots of 2x minus 13. And if I expand this bracket here, x minus 5 times another x minus 5 is going to give us the first term squared. Twice the product, we're going to get minus 5x minus another 5x, so it's going to be minus 10x, and then minus 5 all squared is plus 25. And this is equal to 3 times 2x, which is 6x, and 3 times minus 13, which is minus 39. And I can see I'm almost there now because I've got my x squared. And if I subtract 6x from both sides, minus 10x minus another 6x is minus 16x. And then if I add 39 to both sides, 25 plus 39 gives me 64. And that would equal 0. So that's what I had to show, okay, for 5 marks. So it's important then to remember these rules here, okay, for logs. Now for part B, it says hence or otherwise solve the equation for 2 marks. So again, if you'd like to have a go at this, haven't done so already, just give you a moment to pause the video. Okay, welcome back then if you had a go. So for part B, it's just a question then, if we're solving this equation, just to solve this quadratic equation in x. Now you could use the quadratic formula if you liked, but this one does factorize. We're going to have 2 factors. It's going to equal 0. Those factors are going to be an x and an x there to give us x squared. And for the plus 64, I can see it's going to be minus 8 and minus 8. They multiply together to give plus 64, and you're going to get minus 8x minus another 8x, which is minus 16x. So in the usual way, each of these factors would be equal to 0. Well, they're both the same, so we might as well just say that x minus 8 equals 0. And that leads on to x equaling 8. Okay?